My goal with these videos is to point out the really important things to take note of from each chapter. I apologize for my dog in the background. And I recommend you get a stack of sticky notes and kind of mark up your book as I have. That will make reviewing later on a little bit easier, both for reading quizzes, unit tests, and the AP exam in May. So chapter 1, the case study at the beginning, kind of gives a nice vision of what the future could be, but introduces a very important term, which is really the overarching theme of the book, and that is sustainability. So this idea of how can we make sure that every organism and all of the systems on Earth are able to function long-term in a healthy way that also allows for adaptations to occur. Now, as we get into the first section of the book, 1.1, get introduced to the idea of environmental science, and there's some good vocab to review from biology. So ecology, which is the study of all of the organisms that live in the environment and how they interact with one another. We've got organisms, species. Very important term is ecosystem, because that's what we'll be studying mostly. When we think about environmental science, it's really what's happening in an entire ecosystem. So this includes both the abiotic, the non-living, and biotic living components of the environment. Also introduced on page 7 is this idea of environmental science versus environmentalism. Environmentalism is more like the political and ethical movement, and we will, discuss that briefly, but that's not really the focus of this course. We're really looking at the science that then might help people to make decisions in the political and ethical realms. The 3 principles of sustainability, which will come up again and again and again, are solar energy, which is really the primary energy source for the vast majority of organisms on Earth, biodiversity or biological diversity, and then chemical cycling or nutrient cycling. And we're going to be talking about all of these things throughout the year. Introduced on page 9 in this nice figure is natural capital. It's divided into both natural resources, so these are the materials and energy that we can actually use, including non-renewable and renewable resources, and also natural services. These are processes, sometimes referred to as ecological services, that can either benefit human life or economics as well. So that's something that, again, will come up on the AP exam and throughout the course. Next page, you just get introduced to some ideas that you've probably heard of before, and a lot of these things, again, this is an introductory chapter, so we'll talk about them in more detail. Some terms, perpetual resources, that's something maybe you have not heard of before, but the best example of that is sunlight, because the sun's expected to be here for billions and billions of years. It's not going away. And then we have renewable resources, which take anywhere from a matter of days to hundreds of years to replenish, and then non-renewable resources, which are typically found in fixed quantities within the Earth. They could be energy resources such as fossil fuels, metals, or non-metallic things like salt, sand, etc. Also brings in the idea of reuse versus recycle. Also probably heard reduce, reuse, recycle. Reduce is the best, then reuse, then recycle. But we can't do any of these things, reusing or recycling, with energy because of the laws of thermodynamics, which we get into in the next chapter. The first section of the chapter also introduces this idea of GDP, or gross domestic product. It's kind of a way to measure the economic growth or the health of a country or a region. Also, very important term, which will come up again and again and again, per capita, which means per person. Also get introduced to the idea of the more developed versus less developed or developing countries. Sometimes you might also hear the most developed versus least developed countries as well. And we'll do a lot of comparisons between these regions of the world throughout the year. Section 2, about ecological footprints. We get into natural capital degradation. So we have some good examples up here in figure 1.9. Check those out. Also, pollution. We can divide into point pollution versus non-point pollution. Point pollution is much easier to fix and identify because it's coming from one specific point. Non-point solution tends to be pollution from, I may have just said solution, I'm not sure. It's been a long day. Non-point pollution comes from broader areas, runoff, etc. So it's much harder to prevent and also clean up because it doesn't have one source. Also get into the ideas here of biodegradable versus non-biodegradable. So biodegradable pollutants will naturally break down over time due to natural processes that occur. Non-biodegradable will not. Also, and this is something that comes up often on AP multiple choice questions with cleanup versus prevention. So what's cleaning up pollution versus what is preventing pollution? So look for that throughout the text. We then get into the idea of the tragedy of the commons. We're going to do an activity regarding the tragedy of the commons very early on in the year. It's based on an essay by Garrett Hardin from 1968, which is kind of the beginning of the environmental movement in the 60s. And it's the idea that if resources are common to everyone, public, that everyone might take a little bit, and everyone takes a little bit more, and everyone takes a little bit more, and then it kind of keeps adding up until too many of those resources have been used. Grazing on public lands or fishing in the ocean. Hardin's essay was based on the idea of commons and town commons that had, such as the common in North Reading, where people could let their sheep graze, for example. But if everyone let their sheep graze there as much as they wanted, pretty soon there may not be enough grass to support that area. So it would not be sustainable anymore. So we're going to look at a lot of different examples of the tragedy of the commons. Two general categories for solution: can either have laws or legislation to prevent this from happening or privatize land. Getting into page 16, talking about ecological footprints. Again, something we're going to talk about more in class in the very beginning of the year. But I definitely want you to notice the differences between these two charts here in figure 113, and notice per capita or per person there. That's important. That kind of thing will show up a lot. So when you look at two charts and you're like, how can these look so similar yet so different? So China and India right now, their per capita ecological footprint or resource use per person is much lower than in the United States and Europe. But they're growing very quickly with increased affluence as those countries are becoming more economically developed. Here's your first equation that's not really an equation, the IPAT equation. And basically, the impact that environmental impact that a population has is due to three major factors: the population size itself, affluence, which comes down to like resource use and consumption, and then technology. So we'll talk more about this in class, but keep in mind that both the most developed and least developed countries have negative impacts on the environment, but really for different reasons. For the most developed countries, it tends to do with the affluence, the resource and consumption. And for least developed countries, it's with population growth. Okay. Next page gives you a nice example with a case study looking at China, kind of going into the things that were just discussed. And then on page 19, this introduction of the ecological tipping point. I like to think of it as the point of no return. We haven't reached these points here, but they bring up examples of overfishing, extinction of organisms due to overhunting or overexploitation of those organisms by humans, and climate change. We also have this graph down here at the bottom, 116, which shows the red line is representing population growth of humans. And there's another chart later on that shows the same thing in a little bit more detail, but do be familiar with this idea of the agricultural revolution, which started 10 to 12,000 years ago. The industrial revolution, which began in the mid-1700s, really kicked off in the 1800s. And now we're in what's many refer to as the information age or the globalization revolution. All of these have had impacts on resource use and human population growth. Section 3 of Chapter 1 Got some major causes of environmental problems here. So population growth, human population growth is still exponential. It is slowing down. We're going to do a whole unit on that later on. The unsustainable resource use, which involves a lot of high waste, poverty, and then also the lack of putting environmental costs into the market prices of products. So here's that chart, figure 118 that I was just mentioning, that also shows human population growth. And includes the agricultural revolution and the industrial revolution in there. I just like to point out figure 120, which shows numbers of people, estimates of people who are living in poverty and don't have access to some of the things that we consider very basic, like sanitation and cooking fuel and electricity and clean water. So very important to keep in mind throughout this course that most people in the world do not live like we do. That's very important to keep in mind. And one of the last things that I want you to make note of in this chapter is this term subsidies, because that will come up repeatedly throughout the year. So subsidies are typically provided by the government, so by taxpayers, and they're either tax breaks or payments that help companies to promote jobs, increase the economies, can lower prices of products. But if those subsidies are, for example, non-renewable resources like fossil fuels, it can decrease the availability of resources and increase that natural capital degradation. We get into some worldviews and kind of ethics. I think this is good to read, but there's nothing I feel like that will show up on the AP exam in this section. And then the last section of this textbook, or this chapter, not the textbook, we're just getting started, is, again, this idea of like, so how can we solve these problems? And the idea, individuals matter, which is something that I will stress to you guys as we go through this. And that's kind of the end of chapter 1. Always a good idea. Review the key ideas at the end, and we'll talk about some of these questions later on.